Hello, everybody. Uh, this section is going to be Chapter 10, Section 7, dealing with areas of circles and sectors and segments. First thing that they give you is that an area of a circle is equal to pi r squared. R is your radius. And if you recall, your radius is the point from the center of your circle out to your end of the circle. Also remember we have something called the diameter, and the diameter is the distance from one end of the circle to the next, and it cuts the circle completely in half. So that would be your diameter. Bit of a delay. So this would be your diameter. This would be your radius. Always remember that the radius is always half of your diameter. It's going to be helpful in this section. So they give us, in the first section, they give us, and they got it. They say that it's a circular wrestling region and it has a 42-foot diameter, and they want to know what the area is. So we have some circle that has a diameter of 42 feet. What's the area? Well, remember that area equals pi r squared. Since our diameter is 42, our radius is going to be half of the diameter. So our radius is half of 42. So our radius is 24. So when we plug in our equation, the thing that we're going to square is the 24, since that's the radius. They want our answer probably in terms of pi, so there's going to be two ways of getting the answer. So 24 squared is 576. So if you left your answer, if they specifically ask you for your answer to be in terms of pi, then your answer is going to be 576. Since this is the area, your units is going to be squared, feet squared. If they ask you to round your answer to the nearest tenth, then your answer is going to be 1,809.6 feet squared. A lot of the times they're going to ask you when you do area and circumference to do your stuff in terms of pi. So unless otherwise asked to do it in terms of pi, always round your answer to the nearest tenth. Alright, now we have something called the sector of a circle. And what the sector of a circle is, we have a picture over here. This is circle P, and then this is sector RPS. So a sector is a portion of the circle, a portion of the area of the circle. So in this case, the part shaded in yellow would be the sector, because this is the portion of the circle, or a portion of the area of the circle. So if we remember, area of a circle is pi r squared. It's going to be some particular fraction of that pi r squared. And in this case, they give us an equation where it says the area of the sector is equal to the measurement of arc, in this case of this particular example, measure of arc AB over 360. Remember, 360 is the distance around the circle, so that would be our whole. Our part would be the arc of that. They're both going to be in degrees times the area of the circle. So the fraction of the circle that's being shaded times the area of the circle. Here, for their example, we have a circle. It has a radius of 15. It has a arc length, or an arc of 72 degrees. So we have a radius of 15. We have an arc. This is arc GH. And that's 72 degrees. Our equation for a sector is the sector is equal to the length of GH in degrees over 360 degrees, because that's the distance, that's your hole around the circle, times the area of the circle. So pi r squared. So when we sub it in, we know that MGH is 72 over 360 times pi 15 squared. They want your answer in terms of pi. A lot of times when this happens, you're going to probably have some type of fraction over pi. So this is going to be 72 divided by 4. So it's going to be 45 pi. That would be your answer. It's in centimeters, so it would be 45 pi centimeters squared. If they ask you to round it to the nearest tenth, it would be 141.4 centimeters squared. So they're going to give you some type of part in terms of a degree. Over the whole degree of a circle is 360. That's going to give you your fraction. And you're going to multiply that fraction times the area of the circle, and that's going to give you your area of the sector. So let's look at the got it. So for the got it, they tell me that a circle has a radius of 4. What is the area bounded by the minor arc 45 degrees? So we have a radius of 4. We have some arc. So our arc is 45 degrees. We know that the area of a sector is equal to, in this case, 45 over 360 times pi 4 squared, which equals, again, you would probably have some type of fraction you would have to simplify. I'm not going to do that right this moment, but I'll put it in decimal form. 125 times 16 times pi. And when I do that, I get 2 pi. They say that it's in inches, so it's going to be 2 pi inches squared. Again, if they ask you to put it in decimal form, it would be 6.3 inches squared. But most of the time they're going to ask you to have it in terms of pi. So that's a sector of a circle. Then we have something called the segment of the circle. So we know what a sector is, right? There would be some type of corner going out to the center here. The segment of the circle is going to be a distance right here, and it's going to, these points at the end is going to join the end point of the sector, and we call that the segment. So what the book says is that it's part of the circle bounded by an arc, and the joining and the segment joining its endpoints, and that's called the segment of the circle. So here's the arc, and then here's the segment joining the endpoints of that arc, and that's called segment. And you can get the area of the segment from drawing the minor arc. The radii would be the end segment of that, and you would subtract that from a triangle that's formed from that to get the arc. So here's an example. Here's a picture that they give me. The first part here, this is my sector, and we already know how to get a sector from the previous section. It's the fraction of degrees times pi r squared. And your segment is going to form a triangle from endpoint to endpoint. It's going to form a triangle, and you can subtract that triangle out. And we learned about apophthalms and things of the like from the previous sections that would help us with this particular area of the triangle. You're going to subtract that triangle out, and whatever's left over is going to be your segment. This thing right here, this segment is the same segment as this, and they connect both of the radii together. So I can make a triangle knowing that these two guys are the same distance. It's very helpful. So they give me an example here that has a radius of, it's hard to see, but this is a 60-degree triangle here, or a 60-degree sector as well. It has a radius of 18. They want to have this segment here that's shaded in yellow. So first thing we're going to do is get the area of the sector. And the area of the sector is equal to 60 degrees over 360 degrees. So that's 1/6 times pi r squared. Radius is 18. So times pi 18 squared. So 18 squared is 324. So that's going to equal 324 over 6 times pi. And that's going to give me 54 pi. That's step number 1. We found our sector. Step number 2, we have to we have to find our segment. Step number 2, we have to find our segment. In this case, our segment is going to be that triangle. We know that it's a 60-degree triangle. We know that it's going to form a 30, 60, 90. We also know that if it's a 60-degree triangle, then it's an equilateral triangle, so all sides are going to be the same. So they draw it here for you too, but I'll also draw it my horrible rendition of the same thing. So we have a 30, 60, 90. Since a 60-degree angle has all three sides the same, I know that this is going to be 30. This is going to be half of that. So this is going to be 9. This is 60 degrees. And this is my 90 degrees. So this would be my long leg. I know that from the 30, 60 degree triangle equation that the long leg is equal to the short leg times the square root of 3. So that means that my long leg is 9 square root of 3. But also remember that that's also my apothem for this particular triangle. And it's also my apothem, and it's also my height for this triangle as well, because it forms a 90-degree angle. So the area of a triangle is 1/2 base times height. In this case, my base is 18, and my height is the apothem 9 square root 3. So it's going to be 1/2 18 times 9 times the square root of 3. And that gives me 81 square root of 3. So this is my area of the triangle. So we have my area of the triangle. We have my area of the sector. So the last thing we're going to do is we're going to subtract those two things. So the last thing is the area of the sector minus the triangle, the area of the triangle, and that's going to be 54 pi minus 81 times the square root of 3. Now, a lot of, and it's going to be in what? Inches squared. A lot of textbooks would say that's good enough. They would say solve it. That should be 54 pi. Solve it in terms of pi, and they would say solve it in terms of pi and solve it in terms of a radical. And it also says that in this textbook. They also might ask you to round it to the nearest tenth, and that would be 29.3. 29.3 inches squared. So first thing you do is find the area of the sector. Second thing you do is find the area of the triangle. You're going to have to use 30, 60, 90 or 45, 45, 90 or some type of apothem. That apothem is going to be your height. The base is going to be double the short leg. And that'll get you something in terms of a radical, maybe not. And you're going to subtract that from the area of your sector. And that's going to give you the segment. Okay, so for the got it that they gave us, they give us that the area of the shaded segment is given on the right, and they want us to find out what the section is, the segment is to the nearest tenth. So here we have this triangle. The radius is 4. Notice that it's a 90 degree. So my when I cut that in half, that's going to be 45. So that means that we're dealing with a 45, 45, 90. So first things first, let's get the area of the sector. So the sector is going to be, since it's a 90 degree sector, it's going to be 90 over 360, which is 9 over 36, which is 1 over 4. And we're going to multiply that times pi 4 squared. So that's going to be 1 over 4. Actually, it's going to be 16 over 4 pi, which equals 4 pi. So our sector is 4 pi. Then we're going to find our triangle. So draw it here. So since this is a 90 degree, this guy's going to cut it in half. So this is 90, this would be 45, this would be 45. So it's a 45, 45, 90. This is 4, right? 4 meters. So that's our hypotenuse. And if you remember for 45, 45, 90, the hypotenuse is equal to the leg times the square root of 2. So in this case, it's going to be 4 equals x times the square root of 2. Divide both sides of root 2, so it's going to be 4 divided by root 2. Multiply both sides by root 2 because we can't have that in the denominator. This should all be reviewed for you guys. So this is going to be 4 root 2 over 2, which is equal to 2 times the square root of 2. So the area of our circle is 2 times the square root of 2. So we have 4 pi for the area of our sector. We have 2 times the square root of 2 for our area of the triangle. Actually, no, I take that back. I'm rushing. 2 times the square root of 2 is your leg, or your apothem. So this is going to be our apothem, or our height. So we're not done yet. So area of triangle is 1/2 base times height. So this part here is the same as the leg, which is 2 square root 2. Our base is going to be double that, so this is going to be the same. So if this is 2 root 2, this is also 2 root 2, so I'm going to add them together, so it's going to be 4 square root of 2. So our base is 4 square root of 2. And our height is 2 square root of 2. So this is going to be 1/2 4 square root of 2 times 2 square root of 2. 2 times 4 is 8. 8 divided by 2 is 4. Square root of 2 times 2 is 2. So our area of this triangle is going to be 8. Then lastly, we do the area of the sector minus the area of the triangle, which is 4 pi minus 8. Again, a lot of which equals about 4.6 meters squared. So I think the hardest part of this is probably not going to be finding your sector. The harder part is this. It would probably be trying to find your area of your triangle. But remember, the radii will always be basically your hypotenuse. Most of these triangles will probably be in the form of 30, 60, 90. They might or might not give you the apothem. You probably have to find the apothem, and then that'll help you find your third side. If your third side is the base that you're looking for, you're going to have to double that, because the base, that side is always going to be half of the cutting part of the apothem. Once you find the area of your triangle, you subtract that from your sector, and that's going to give you the area of your segment. Alright, so let's do a couple questions and then we'll be done. This one says to find the area of your shaded circle, leave the answers in terms of pi. So if we look at number 2, they want you to find just the sector. So remember that sector is equal to some arc over 360 degrees times the area of the circle. In this case, the radius is 9 and the arc is 75 degrees. So it's going to be 75 over 360 times pi 9 squared, which is 75 divided by 360. They want your answers in terms of pi. So I'm going to divide top and bottom by 5, so I get 72. I believe this is 15. I think I can divide that again, can I? Yeah. Which gives me 5 over 24. So it's going to be 5 over 24. 9 squared is 81, so times 81 over pi. And I get 16.9 pi, and it's going to be inches squared. So they ask you to have your answer in terms of pi. So I'm going to leave it right there. 16.9 inches squared. We're rounding to the nearest tenth with that. So it was 16.875. I rounded it to the nearest tenth. That's 16.9, and I left it at 16.9 pi. So that's that one. Number 3. They want you to have the area of the segment. So remember, this is going to be this sector minus this triangle is equal to that segment. Notice that this is 2, so that means that this will be my hypotenuse when I cut this triangle in half. Notice that this is 120 degrees, so this is going to be cut into 60. So if I was to draw the triangle out, well, first it's going to be the area of the sector minus the triangle, and that's going to give me my area of the segment. So first things first, the triangle, the sector. Sector is 120 over 360, which is 12 over 36, which is 1/3, times pi r squared. The radius is 2, so pi 2 squared, which is 4, so it's going to be 4/3 pi. So that's our sector. Again, they said they want you to leave your answers in terms of pi, so that's 4/3 pi. Our triangle, we're going to have to draw this one. So it's 120 degrees, but we're going to cut it in half because we need a height. That will make this 60. That will make this 30. This is 2. That's our hypotenuse, which means that this height here would be my short leg. Remember that the hypotenuse for 30, 60, 90 is equal to the short leg times 2. Since the hypotenuse is 2, we divide both sides by 2. So that short leg, or the apothem, or the height is equal to 1. So this is going to be 1. Also remember for the 30, 60, 90 that the long leg is equal to the short leg times the square root of 3. So in this case it's going to be 1 times the square root of 3, or just the square root of 3. So this guy over here is the square root of 3. But I need the whole entire base. So this is square root of 3. This cuts it in half. This is also square root of 3. So I add them together, and the base is equal to root 3 plus root 3, which is 2 times the square root of 3. The height is the same thing as the apothem, which is 1. So the area of the triangle is 1/2 base, which is 2 root 3, times the height, which is 1. 1/2 times 2 cancels out. Square root of 3 times 1 is 1. So the area is the square root of 3. The area is the square root of 3. So I have my area of the triangle, which is square root of 3. I have my area of the segment of the sector, which is 4/3 pi. All I have to do is subtract them. So my final area, they want it in terms of pi. It's going to be 4/3 pi minus the square root of 3. And that's it. That's all I do. I don't have to do any more math. And this is meters squared. That is my answer. 4/3 pi times this minus the square root of 3. The area of the sector minus the area of the triangle. That's number 3. Again, the hardest part of this is probably not going to be the sector. The hardest part of this is recognizing your triangles and whether the 30, 60, 90, 45, 45, 90, or something where you have to use the Pythagorean theorem in order to solve. I think I want to do one more of these. Of the sector one. So for let's look at number 17. They want the area of the shaded region. So notice that we have this huge sector region here, and we have this small region here. So the small region has a degree of 90. So in order for me to find the bigger region, I know that a full circle is 360 degrees. So a full circle is 360 degrees. They give me part of the circle, right? This part of the circle is 90 degrees. So in order to find that big shaded region, all I have to do is subtract those guys. So I would subtract 360 minus 90, and I have 270 degrees. So that's going to be the big shaded region. Or the shaded sector. So when I do this, I'm going to use my sector equation. Sector, the radius is 4, is equal to, in this case, 270 over 360. So that's 27 over 36, which equals, divide by 9, that's 3 fourths, times pi r squared. So my radius in this case is 4. Which means that we have 3 fourths times pi 4 squared, which means we have 3 times 16 over 4, which means we have 4 times 3, which is 12 pi. And it's going to be 12 pi feet squared. 12 pi feet squared. So I subtracted 90 from 360 to get the area of the shaded segment, the big area of the shaded segment. Then I used my sector equation. 270 over 360 returns into 3 fourths, pi r squared. Radius is 4, so 4 squared is 16. I divided 16 divided by 4 to get 4. 4 times 3 is 12. I get 12 pi. Let's do one more sector, or segment, because I know how much you guys love that. So let's do number 24. They want us to round our answer to the nearest tenth, so in this case they don't want any pi or radicals. So we have this circle. It's 90 degrees. They want the area of that segment, so it's going to be, in terms of our equation, it's going to be the area of the sector minus the area of the triangle, and that's going to give us our area of the segment. So that's That's what's going to set us up. So the first part is the area of the sector. We know that sector is some portion of it. In this case, it's 90 degrees. 90 degrees over 360. Divide top and bottom by 9. That's 1/4. Times pi r squared. Our radius is 8. So 8 squared is 64. So times 64 pi, which is going to be 64 over 4 pi. What does that give me? So it's going to be 16 pi. So that is the area of our sector, 16 pi. Then we get the area of the triangle. Since it's a 90-degree triangle, that tells me I'm probably going to deal with a 45, 45, 90. So I'm going to cut that in half. That's my 90 here. This would be 45. This would be 45. Why does it keep drawing my fours like that? Damn it. Darn it. This is going to be 8, right? This cuts it in half. Wait. Yeah, this cuts it in half. That's going to be my 8, which also makes this my 8, which makes this part the hypotenuse. This hypotenuse is going to be, remember, hypotenuse is equal to the leg times the square root of 2. So this is going to be 8 times the square root of 2. I don't think that's important though. That's 8, and that's 8 because it cuts in half, so we add those together, so that's going to be 16. So our base is 16. Our height is 8. So our area of a triangle is going to be 1/2 base times height, which is 1/2 16 times 8, which is 8 times 8, which is 64. Huh. Which is 64. Which is interesting. I made a mistake somewhere. Let's see. I cut that in half. Nope. My mistake was that made a mistake. Redraw. Start over. It is a 45, 45, 90, but my hypotenuse is 8. My hypotenuse is 8. So I have to find the leg and the base. So using that equation up here, my mistake. We have 8 equals my leg times root 2. Divide both sides by root 2. So this is going to be 8 over root 2 equals my leg, top and bottom by square root of 2. That's 8 root 2 over 2, which gives me 4 root 2. So my leg is 4 root 2, so this is 4 root 2. This is also 4 root 2. So I add those two guys together and it's going to give me 8 root 2. Since this is the same as the height, the hypotenuse is the same, that's going to also be 4 root 2. So my height is 4 root 2. My base is 8 root 2. So when I do the area of the triangle, one half 4 root 2 times 8 root 2, that's going to be 2 times 8, which is 16, times 2, because root 2 times root 2 is 2, which is 32. That makes more sense. So then when I do the segment, it's going to be the sector minus the triangle. So it's going to be 16 pi minus 32, which gives me 18.26, which rounds up to 18.3. 18.3 feet squared. And that would be our answer. (18 feet squared). So, first thing I did was I got the area of the sector, which was 90 over 360, which turned into 1/4 pi r squared, where r is 8. So that's 64. 64 over 4 pi gave me 16 pi. When I did the triangle, it's a 90-degree triangle, so that cuts it in half to make a 45, 45, 90, where the 8 is the same thing as your hypotenuse. That was my mistake. I made it a leg, but it is the hypotenuse. So I did, for the 45, 45, 90, the equation is hypotenuse is equal to the leg times square root of 2. I divided both sides by square root of 2. So 8 over square root of 2, we can't have a radical in the denominator, so I multiply top and bottom times square root of 2, which gave me 8 root 2 divided by 2, which is 4 square root of 2. The leg are both the same for 45, 45, 90. So since they're both the same, the height is 4 square root 2. I would have to double this to get the whole entire base. So the height's 4 square root of 2. The base is 8 squared root of 2. Our equation for a triangle area is 1/2 base times height, where the height is 4 root 2 and the base is 8 root 2. So we have 1/2 times 4 times 8, which is 2 times 8, which is 16. Square root of 2 times square root of 2 is 2. So 16 times 2, which is 32. And then lastly, I just subtract them. 16 pi minus 32 gave me 18.26, which rounded up to 18.3 feet squared. Okay, so those are a couple of examples for section 10.7. Have a great rest of your day, guys.